And let's ready to learn capacitance of parallel plate capacitor with completely filled dielectric medium between the plates. Here we have taking two parallel plates. Let us take two parallel plates of plate area A each. Distance between two plates is D and these plates are connected across a potential difference V. V is the potential difference. So charge Q will be moved from the potential source and plus charge will accumulate on this plate and minus will accumulate on this plate. Let us completely fill it with mica sheet of dielectric constant K, or you can say epsilon R, relative permittivity. Then here this will be rearranged like this. This is arranged like this. This is dielectric molecules. So minus charge will come here, plus here, minus here, plus here, minus here, plus here, minus here, plus here. This plus and minus given on the plate produces electric field E naught from plus plate to minus plate. And this plus and minus produces electric field E P due to polarization from right hand to left hand side. So this two electric field produces a new electric field which is known as E, and E equals to E naught minus EP. Since E naught is greater than EP, so direction of E is along E naught. Here the mica sheet's dielectric constant is K or epsilon R. This is dielectric constants K. Now what will happen here? You have potential V upon D is equals to electric field E. So electric field E is equals to sigma by epsilon. So it is equals to V upon D. So you have sigma equals to Q upon A epsilon. It is equals to V upon D. So you have V is equals to Q D upon A epsilon. Now C is equals to Q upon V. Put the value of V here. So it is equals to Q D upon A epsilon. Cancel this Q. So you have A epsilon upon D. Now you know that epsilon upon epsilon naught is equals to epsilon R or K, dielectric constant or relative permittivity. From here epsilon is equals to epsilon naught into epsilon R, or you can write epsilon naught into K. So we use the value of epsilon at this point. So the formula C become epsilon naught K A upon D. So this is equals to C is equals to K into C naught, because C naught equals to A epsilon naught upon D. You know this formula, it is known by you. So we have C is equals to KC naught. Thus what we see that C is greater than C naught. Just you have learned what is capacitance of parallel plate capacitor with completely filled dielectric medium. The equation is C equals to K C naught. Let us have numerical based on this. Numerical number 1. Here suppose there are two plates, they are connected with a potential source, and when there is a vacuum between the plates, then the C naught is equals to 8 picofarad. Let us see, C naught equals to 8 picofarad, distance is D. Now what will we do? We will reduce the distance to D by 2. Now the distance become D upon 2. Distance become D upon 2. This distance become D upon 2 half, and they are still connected with the same battery source, V potential. Now put mica sheet K equals to 6. Now what will be the new capacitance? This means that you have to find C equals to what? You know the formula. C is equals to K C naught, and here you have K. C naught is A epsilon naught upon D. Since distance is reduced to D by 2, so therefore you will write C dash is equals to K A epsilon naught upon D dash. This is K A epsilon naught upon D upon 2. So you have 2 K A epsilon naught upon D. So 2 K A epsilon naught by D is said to be C naught. So it is 2 into K is 6 and C naught is here 8. So it is 2 into 6, 12 into 8, which is equals to 96, and it is picofarad. Just we have seen numerical number 1. Let us see second numerical based on this. In this second numerical, I am giving you two parallel plates. Here let us take two parallel plates, plate number 1, plate number 2. A plate area is given to you, which is 6 10 to the power minus 3 meter square. Let D is equals to 3 mm. D equals to 3 mm. Then in this situation, these two are connected with a potential source. Let connected potential source V equals to 100 volt. Now here charge Q. What will be the value of charge Q? And what is the value of C naught? There is no mica sheet inside, no dielectric. Then what will happen to C and Q naught? You have to find for number first. Number first, A case, you have to find C naught. C naught equals to A epsilon naught upon D. So A is equal to 6 10 to the power minus 3. Epsilon naught is 8.854 10 to the power minus 12. And D is 3 into 10 to the power minus 3. Cancel this. 3, this is equals to 2. Multiply 2 into 4, 8. 2 into 5, 10, 0. 2 into 8, 16, 17, 2 into 8, 16, 17, 10 to the power minus 12, here 1, 2, 3 point is here, so you can write this is nearly 18 picofarad. So C naught equals to 18 picofarad. Part number A, number first in A, number second in A is you have to find charge Q. Charge Q is equals to C naught into V. So C naught is 18 picofarad and V is equals to 100 volt. So you have 1800 picocoulomb. So in the first case, you understand what you get C naught and what you get Q. I am writing here, you get C naught is equals to 18 picofarad and you get Q is equals to 1800 picocoulomb. Now second part of the same numerical. If the numerical asks from you that the power source is still on and a mica sheet is placed between this and K equals to 6, mica sheet is placed between this. Then in this situation, C converted to C dash. You have to find C dash, and charge converted to Q dash. You have to find Q dash. And you have to find voltage V dash. So number first, what will be C dash here? C dash equals to K into epsilon naught, K into C naught. What is K? K is 6 and C naught is still fine, which is 18 picofarad. So this is 6 into 8, 48, 6 into 1, 6 plus 4, 10, 104 picofarad, C naught, C dash. Now next you have to find charge. First part you have, now second part is charge Q dash. Q dash is equals to C dash into V, because potential will be not changed, potential is still applying the same potential. So this is equals to 108 into 100. So this become 10800. This is picocoulomb. So this is the charge. Now the third part of the question is, this is B part, you have learned B part. Third part of the question is, first of all we disconnect the battery. Here we are disconnecting the battery. After disconnecting the battery, we will place the dielectric constant material K equal to 6. Then what will happen to capacitance C double dash. Now you have to find C double dash in situation, and Q double dash. What will we have to charge? Since potential will be disconnected, so you have to find V double dash also. So in this situation, what will be going to be happen? Now third case, C case. Here in this situation, you have to find first of all C double dash. C double dash equals to K C naught. So K C naught, K is already 6 here, and C naught is 18. So this is equals to 18 picofarad. This is equals to 108 picofarad, no change. C dash will be same. But what will be the charge Q dash? Q dash double dash will be same as in the case of first case. That is Q double dash is equals to Q, the charge in the first case, no change on the charge, that is equals to 1800 picocoulomb. This is the charge here. Now you have to find number third. V double dash potential will be what? For finding this, you know that Q double dash is equals to C double dash into V double dash. So V double dash equals to Q double dash upon C double dash. What is the value of Q double dash? Q double dash is 1800 picocoulomb. And what is C double dash? This is 108 picofarad. Pico will cancel out, it becomes 1800 divided by 108. Divide it and you get the answer. It is you get the answer 16.6 volt. Thus you have learned about capacitance of parallel plate capacitor with completely filled dielectric and numerical based on this. Do like, subscribe and share my channel. Thank you.